So last week we practiced solving systems of equations with all the different types of methods. And today we're going to talk about how to identify which method is best to use depending on what your equations look like. So you can really use any of the methods, but we'll kind of look at some examples and talk about how to identify which method is the most efficient and which one is the best. So with graphing, we can really use graphing with any type of equation. If both of the equations are already in y equals mx plus b form, it's really easy for us to put it on a graph and solve from there. But you can really use graphing with any type of equation. The next method is substitution. Now, you want to use substitution when a variable has already been isolated. So in this first example here, we already have y isolated, and so it's really easy for us to just take y and plug it into our other equation. In our next example below, x has already been isolated, so it's super easy for us to just take x and plug it into our other equation. So if you see y equals or x equals, it would be the most efficient to use substitution. Okay, next we have elimination, and we can use addition or multiplication when eliminating. So we want to look for additive inverses. Additive inverses are terms that are kind of like opposites. So 2x and negative 2x are examples of additive inverses. When we add the equations together, those x terms will cancel out and we can solve for y really easily. So from here we would get negative 6y equals 6. And from there I can solve for y, plug that back in to find x. In my second example here, y and negative y are additive inverses. So when I add my two equations together, the y's cancel out, and we have 4x equals 12. So it's easy for us to solve for x from there. The other elimination method is multiplication. So this is when we create our own additive inverses. So if you don't see any additive inverses, but all of your terms are lined up, our x's are lined up, y's are lined up, equal signs lined up, and our constants are lined up, we can multiply across one of our equations. So here, if I multiply across my second equation by 6, and I distribute that 6 all the way across my equation, my x term will be negative 6x. And so, of course, when I add them together, 6x plus negative 6x is 0, so those are going to cancel out. In my second example here, we have negative 2y and negative 2y. So if I multiply by negative 1 across either one of my equations, I'm going to pick the top one. If I multiply all the way across, my y term will become positive 2y. So when we add our equations together, our y terms will cancel out.